Hi Year 12, this is another short video just to show a dehydration reaction or an example of an elimination reaction to go from an alcohol back towards an alkene. I've used ethanol as an example, so I'll go from ethanol through to ethene. Right, for this mechanism, it needs to be done at a high temperature of roughly 170 degrees, and it needs to have an acid catalyst, for example, sulfuric acid or phosphoric acid. I much prefer to use sulfuric acid for this because that way you don't get confused between this mechanism and hydration. For hydration, you need to have phosphoric acid, and for elimination, you need to have sulfuric acid. It just makes life a little bit easier. So, you know that oxygen in the alcohol group on the alcohol has a lone pair, or has two lone pairs of electrons as drawn very small in red. Those lone pair of electrons can attack a hydrogen that is in the sulfuric acid, because the hydrogen is partially positive and the oxygen is partially negative. So a lone pair of electrons from the oxygen will attack the hydrogen, causing the electrons in the hydrogen and oxygen bond to move towards the oxygen. What you've now ended up producing is, remember these hydrogens all stay the same, an oxygen that now has 3 covalent bonds because it's removed this hydrogen from the acid. We want to go to an alkene. So we want to remove this OH and we want to remove another hydrogen. For this reaction, it is known as a dehydration reaction because you're removing water, which means this molecule needs to be removed. We need to get rid of it. So if we need to get rid of this molecule, that must mean that the electrons from this bond move towards the oxygen. If we now draw out what we have, well, what we've ended up with is this carbon, which still has 3 hydrogens, a carbon over here, and this. Well, you know we've got to have an alkene, which means one of these hydrogens also needs to be removed. So if one of those hydrogens is removed, the electrons move towards the carbon-to-carbon double bond. If the electrons have moved towards the carbon-to-carbon double bond, that means I don't have any use for this hydrogen over here because it doesn't exist anymore. So actually, we'll remove it. And if we've got the electrons moved towards the carbon-to-carbon double bond, we've now produced an alkene. You may be thinking, well, where does this hydrogen suddenly disappear to? Where does it suddenly go? How have we just removed it? Well, the way that we've removed it is via this. This sulfuric acid that exists has a negative charge and a lone pair of electrons, which will then remove that hydrogen. And that is how that hydrogen becomes removed and why we ended up with an alkene. I hope that made a bit of sense, but you will have a lot of practice for this, and this is also part of your 6-mark question, except it's not with ethanol. I think I set it for you with butanol, but I might be wrong. Oh no, I did propan-2-ol. It is important that when you do this, that you remember the types of catalysts you have and how this hydrogen has been generated. In the caboodle textbook, it does not go through how that hydrogen has been generated, but you know that there is a catalyst for a reason. It means it can be regenerated at the end. I hope that helped.